is GATE 2014 Set 1 EE question number 32. It says the four vector fields are given in Cartesian coordinate system. Vector field which does not satisfy magnetic flux density property is, four options are given. Now for solving this you need to know what property the question is talking about. So you need to know Maxwell's equation. So curl of E is minus dv dt, which is Faraday's law. Curl of H equal to J plus dt dt, displacement current, that is displacement current plus the current density, which is given by Ampere's law modified form. This is both are in differential forms, and divergence of the electric field density vector, so that is charge density, volume charge density. This is given by Gauss's law. And last one, this property, this Gauss law for magnetic field, stating that the divergence of magnetic field, that is magnetic flux density, is always 0. This is because magnetic monopoles cannot exist. So if north pole, out of north pole a flux line is coming out, it will come back and went to south pole. Right, what we are talking about is like this. You see north pole, south pole, you enclose it by a closed surface. North pole, this vector is coming out and it is going in south pole, and then inside it is south to north. Now one flux line cuts here out and one in, so net divergence is 0. So this is what is the property, magnetic flux density, that divergence of that is 0. So what is divergence now? Let's see. Divergence of any vector field B, which is given by bx plus by plus bz, x component, y component, z component, is given by a dot product with this operator is nothing but this dot product ddx I cap, ddy j cap, ddz k cap with the vector field. Now this comes out when you do the dot product. I dot I is 1 and others are 0. Again j comes dd by by and k dot k 1, so this dz term only comes, so dvz dz. So we have to do only take the x component of the vector field, derivative it, plus take the y component, derivative it with respect to y, take the z component, derivative with respect to z, and then sum it up. So coming to the solution, just see, all these are plus, right? So you need to find if we need to do divergence of B is 0, divergence of B is 0, B equal to mu h, so divergence of h is also 0. Now what is this? ddx of this is 0, ddy of this is 0, ddx of this is z of this is 0, because you see x component should not contain any x term, then it will be 0. But here you see, here also x component should not contain x term, y component should not contain y term, z component should not contain z term, else it will be non-zero. We want 0, but here you see it is coming non-zero, so this one is the correct option. You understood the logic, right? So rather I should tell it as a shortcut, since you see B vector is having positive components of x, y, z, so x component should be free of x terms, such that ddx of that vector field is 0. Similarly, other y component should not contain y term, y component should be free of y term, z component should be free of z term, such that sigma of d di bi, where I is x, y, z, is 0. Then only the property should be satisfied. Where it is not satisfied, that is the correct option, because C, which is not satisfying, which of the vector field is not satisfying this is not satisfying, so this C, option C is the correct.